Hello children, welcome to aimsindia's online classes. In today's class, from physics subject, motion topic we are going to continue. Our today's concept is children regarding this oblique projectile. Oblique projectile means a body thrown from the ground with an angle alpha other than 90 degrees. Other than 90 degrees, it will be called as a projectile. It will be called as a projectile based on its path, based on the path traveled by it. So we can call it as oblique projectile. Oblique projectile, or its path is also called as trajectory. Path of projectile is called as trajectory. Here, OX is the ground, OY is the vertical line which is making 90 degrees with the ground. We have to project a body. We have to throw a body with an angle alpha with the ground, which is other than 90 degrees. Which is other than 90 degrees with a velocity u, with a starting velocity or initial. Starting means we call it as initial. With the initial velocity u, we are throwing the body, and the body is traveling in this path. Body is traveling in this path. So this is called trajectory, and this is called oblique projectile. So we are going to learn about some of the formulas related to this oblique projectile. So in this oblique projectile, so throughout its journey means from the point of projection from O to point P to point A to point B. So on the whole, so many terms are involved in this projectile. First of all, we have to know about that terms here. So in oblique projectile motion, horizontal component of velocity u cos theta, acceleration, mechanical energy remains constant. Means here, so we are throwing with a velocity of u, which can be resolved, divided into two perpendicular components, because this u we are projecting with some angle. Suppose if it is theta, with some angle theta with the ground, which can be resolved into two mutually perpendicular components. So this is in x direction, this is y direction. These x and y are mutually perpendicular. So then this u can be resolved into two components, because oblique projectile is a two-dimensional motion. It's a two-dimensional motion. It will be having two or more components which are independent of each other. So here u can be divided into one component. Suppose if it is 40 meter per second, out of 40 meter per second, some part will work in the direction of x, some part will work in the direction of y. So this the part which is working along x, it is known as horizontal component of velocity, denoted by u cos theta. So here u is the velocity with which it is thrown, theta is the angle made with the ground. In trigonometry, you will come across this cos theta. So horizontal component value is u cos theta. In the same way, vertical component, the velocity acting along vertical direction will be u sin theta. U sin theta will be vertical component. So, but in the projectile, when it is traveling in the air, while throwing, we are throwing with a velocity of u, but after that it is traveling by its own, without the help of any fuel, without the help of any external force. It is traveling by itself. It is affected only by the acceleration due to gravity. Acceleration due to gravity g value, which is caused because of the gravitational force. Means throughout its journey, it is affected by gravitational force which is acting vertically downwards. Means we can observe change in the vertical component of velocity throughout its journey, but horizontal component of velocity, as there is no force acting in horizontal direction, it will be constant. So throughout the journey, this u cos theta, horizontal component of velocity, is constant. That is one constant. Throughout its journey, it is acted by acceleration due to gravity z. So this acceleration due to gravity z, which is 9.8 meter per second square at this place, is also a constant. And one more thing, at any point, it will be having kinetic energy and potential energy. Kinetic energy and potential energy. So kinetic energy means energy due to its velocity, because as velocity changes, kinetic energy also changes. Potential energy means energy due to its position. As the height of the particle is changing continuously, potential energy also changes continuously. So throughout the journey, for the body, kinetic energy of the body will change, potential energy of the body will change. But we have one law of energy conservation. Energy can neither be destroyed nor be constructed. It will be conserved. Means though kinetic energy may change, potential energy may change, but kinetic energy plus potential energy, there's some mechanical energy will not change. If kinetic energy is 40, potential energy is 10. After some time, kinetic energy 30, potential 20. After some time, kinetic 20, potential 30. Kinetic 10, potential 40. But at any condition, overall energy will be 50 newtons. Like that. So mechanical energy also constant here. So u cos theta, horizontal component of velocity constant, acceleration due to gravity z is constant, mechanical energy will be constant throughout the oblique projectile. These three are constant. So whereas when the body is moving, if we compare 1.2 at P point, at A point, at B point, at all points, speed of the particle changes, overall velocity of the particle changes, kinetic energy of the particle changes, potential energy of the particles changes, momentum means product of mass and velocity, mv, momentum of the body changes. These all things will change. Which one? How vertical component of, along with that vertical component of velocity, u sin theta, vertical component of velocity acting in y direction, this u sin theta will changes. So vertical component of velocity changes, momentum changes, kinetic energy changes, potential energy changes, speed changes, velocity changes. So all these things will change. All these things will change. All these things will change. So you might be getting questions, children. Which of the following constants changes in oblique projectile motion? Or which of the following are constant? At the time, you have to remember the constant things are horizontal component of velocity. Y means in that direction no force is working. Acceleration due to gravity created by gravitational force, which is always constant at a place. Mechanical energy, because energy is neither conserved nor created. These three are constant. Which are not constant? Speed, velocity, vertical component of velocity, kinetic energy, potential energy, momentum, mass into velocity. All this will change. But while throwing the body at the point of projection, so this is O is point of projection, from where we are projecting the body. At O, means at O, at point of projection, velocity will be maximum. Velocity will be maximum because we are throwing from here, we are starting throwing, so there velocity will be maximum. If velocity is maximum, kinetic energy also will be maximum at O, means its starting point. So potential energy will be minimum. Potential energy will be minimum at this point. So what is the highest point reached by the body? It's A. Highest point reached by the body is A. So there velocity is minimum, almost zero, but not completely zero. We have to tell almost zero. Their velocity is minimum, kinetic energy is minimum, potential energy is maximum. Potential energy is maximum. So at the point of projection, at the highest point of oblique projectile reached by oblique projectile, their velocity is maximum, potential energy minimum. Here minimum, maximum. So the velocity and kinetic energy are maximum at point of projection, minimum, but not completely zero at highest point. Next here, let's see some equations here. So here, so equation of the oblique projectile or trajectory, because the path of projectile is called as trajectory, we can call it as equation of oblique projectile or directly equation of trajectory. So a projectile thrown with a velocity u at an angle theta with the horizontal, the velocity u can be resolved into two rectangular components, u cos theta along x-axis, u sin theta along y-axis. So y horizontal is u cos theta, vertical is u sin theta, means in trigonometry topic, in mass part you can learn that, children. So here directly we can remember rectangular component u cos theta, vertical component u sin theta. So then suppose this is a u, so horizontal component, this is u, horizontal component u cos theta. Suppose x for horizontal motion, x, so distance traveled horizontally, x, suppose it has traveled a distance of x units from the point of projection O, So then how to calculate distance? With what velocity it has traveled, how much time it has traveled, velocity into time. So here actually it's a straight line, we have to call it as displacement. Displacement equal to velocity into time, or distance equal to speed into time. Speed is u cos theta, time is t. So x equal to u cos theta into t. So t equal to this u cos theta will come this side, x by u cos theta. We are getting this first equation. So for vertical motion, so for horizontal motion, as velocity is constant, direct formula speed into time we are using. But for vertical motion, it is not a normal body. It is traveling with uniform acceleration. It is traveling under uniform acceleration created by gravitational force or created by gravitational acceleration due to gravity. So we have to take equations of motion. we have to consider equations of uniformly accelerated bodies. That equations we have to take. With normal equations we cannot write. Here children, vertical motion. Here children, vertical motion, this along the entire path, this whatever vertical motion is there, it is an example of uniformly accelerated body under the influence of gravitational force, or acceleration due to gravity will be created in the body. So the vertical component of a body, for that we have to consider the equations of motions of uniformly accelerated bodies. So we have to take this formula, S equal to ut plus half at square, where S is the distance traveled. So vertical motion means it is traveling in y direction. Let the distance traveled be y. Ut. Ut means u means beginning velocity. So vertical component. What is the beginning velocity? In vertical component, velocity is u sin theta, because u is divided into u sin theta. So in the place of u, we can keep u sin theta. Time. Because for horizontal motion, what time we have considered? Same body, same time we have to consider. So we will keep t like that only. So vertical motion means body is going upwards. Acceleration is acting downwards. So this g value will be negative. G value will be negative. Why means the motion of the body, acceleration due to gravity are opposite to each other. If motion of the body is taken as positive, then acceleration acting downwards will be negative. So minus z. So minus half z, in the place of t we will keep t only, t square. So this is the formula. So y equal to u sin theta. So what we got? Here we got y equal to u sin theta t minus half g t square. So where u sin theta, in the place of t we can keep here x by u cos theta. In the place of t we can write x by u cos theta minus half z. In the place of t we can write u cos theta whole square. U cos theta whole square. There sin theta by cos theta we can write as tan theta. So u gets cancelled. Sin theta by cos theta. When we have sin theta by cos theta, so directly we can write as tan theta. So x tan theta. Here u cos theta whole square means, sorry, here x by u cos theta. So here in the place of half gt square, t value is half into g into t value is x by u cos theta whole square. So what we can write? G into x square by u square cos square theta. U square cos square theta. This we can write. So this is x term and this is x square term. If this tan theta, if we take it as a, if before x square whatever term we have, if we take it as b, so then we have equation y equal to ax minus bx square, or we can write it as minus bx square plus ax equal to y, which is in the form of ax square plus bx plus c equal to 0, means quadratic equation. So the equation of oblique projectile or equation of trajectory is in the form of quadratic equation. So quadratic equation always will be represented on the graph with the help of parabola curved downwards, parabola curved upwards. The equation of quadratic equation will be like a parabola curved downwards, like a parabola curved upwards. So the equation of projectile also trajectory are also parabolic, because it is similar to equation of quadratic equation or equation of parabola. Equation of parabola. R. This equation can also be written as, we can take x tan theta common. So y equal to x tan theta common in the brackets 1 minus x by r, where r is horizontal range. Means from here we have thrown the body up to what point it has reached. This distance is called horizontal range, which is r, whose value is u square by sin 2 theta by z, u square sin 2 theta by z. In terms of r, we can write y like x tan theta common 1 minus x by r, 1 minus x by r. Like this also we can write. How we have written like this, we will be learning later. So here, children, so that's why here we have got the projectile, or we have drawn the projectile as a parabola. Why? Means projectile equation will be similar to parabolic equation or quadratic equation. So its shape will be like a parabola, and its equation we can write in two ways. So one is, so y equal to x tan theta minus half. So here what? Minus half g x square by u square cos square theta. This is the equation of trajectory. Or y equal to, it is in the form of ax minus bx square, or it can also be written as y equal to x tan theta common 1 minus, in terms of range we can write it as 1 minus x by r, where r is the range. Means horizontal distance traveled by the body. Actually, why we have how we have got this means, previously we have y equal to x tan theta. Previously we have y equal to x tan theta minus half g x square by u square cos square theta. U square cos square theta. So okay. Anyway, later because we have not learned about range, children. Actually, for range also we have derivation. After learning the range derivation, we can convert this into equation into range. That we can learn later. Okay, children. Today we have learned about oblique projectile. Which are constant, which are not constant. Equation of projectile we have learned. So only that's all, children. So remaining some topics out there we can learn in our next video. So thank you for watching our video, children. Please subscribe our channel and press the bell icon for receiving latest updates. Thank you, children. Have a good day.